Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation platform for all competitive exams, BYJU'S Exam Prep, and warm welcome to the GATE 2024 Rankers Monsoon Series. Join the session quickly and mark your presence. In this monsoon series, we are learning very useful and important topics that are chosen by you. In the last class, we have already learned how we can find the time complexity of the given code, and today let us learn what about nested structures and unions. This is again a very interesting topic, very important topic, dear friends. So whoever have joined the session, please confirm, am I visible and audible to you clearly or not? Are we good to go with nested structures and unions? Please confirm in the chat box. Let me start with a quick introduction of mine. I am Satya. I am a research scholar with 15 plus years of teaching experience. I have mentored more than 40,000 students all over India in the GATE and PSU categories. I teach programming and data structures, operating systems, computer networks, computer organization and architecture, and algorithms. And the other credentials you can find here. Yes guys, am I visible and audible? Please confirm in the chat box. Okay, so guys, nested structure union, before we discuss, it is very much required to understand what is the structure or union in programming and the C programming. So what is a structure or union? Whenever we group similar data, we know that is called as an array. But when we group dissimilar data, so group of dissimilar data or heterogeneous data, that set of dissimilar or heterogeneous data is what we call as structure or union. So how we can create such a structure? With the keyword struct or union, name of the structure followed by what data we wanted to group, all those data items we will write in the structure block or union block, ended with semicolon. For example, struct person details. Suppose I would like to create a structure as person details. What a person will have as detail? Name person will have. So name I am creating as a string. What else? Address. What else? Gender. And a person may have age, right? So if you just observe this a simple structure, what I have grouped here? I have grouped the character array name, address, and a character gender and age. So these are dissimilar data. Not all are integers, not all are characters, but I have grouped these. So such group I call as a structure or union, right? Now in the structure we have the terminology. The anatomy of structure or union is like the data items defined inside the structure or union are called members, and the data items defined outside the structure or union are called variables. So if you look at, I have taken a struct or union keyword with the name, and whatever the data I wanted to group, I have kept inside, and I have created some variables outside the structure. So whatever you have inside the structure we call as members of the structure or members of the union. Hi Trivikram, good evening. And whatever we have defined outside this structure or union we call as variable. So members, variables. I think this terminology is clear. Hello Arun. Yes, is this terminology clear? What are members and what are variables for the structure or union? Right. Now, how you can access any member of the structure or union? You can't access any member directly. You have to access through its variable. So to access any member of the structure or union, it is possible only through variable. How you can access? If the variable is a normal variable, we will access with dot operator. How? Variable dot member. And if that variable is a pointer variable, with the forward arrow operator, we can access variable arrow member. For example, there is a structure struct XYZ. Let's say int I, float j, v1, v2. So here what are the members of this structure XYZ? I, j. And what are the variables? v1, v2. Right. So if I would like to access I, j, you can't access directly in the scanf or printf while you do some operation. Then how you can access? Through variable. So if you want to access v1 members, you can access as v1.i or v1.j. Why? Because v1 is a normal variable. And if I would like to access through v2, then I can access it as v2 arrow j or v2 arrow j or v2 arrow I, because v2 is a pointer variable. Got it? What does this member access means? If it is a normal variable, we use a dot operator. If it is a pointer variable, we use forward arrow operator. Guys, this structure is the base for classes in the object-oriented programming. Like you observe, like how you use the keyword struct here, there we use the keyword class in object-oriented programming language. And like how we have this variable of the structure, there we have the variable of the class, which is called object. And object itself is like a pointer. That's why there you can directly access the members through object, but there we will not use arrow operator, but we use the dot operator only, ob.i, ob.j, isn't it? So structure is the base for the class in object-oriented programming. Of course, inside the structure we can't define functions, but inside the class we can define methods. Yes, we have some differences, but structure is the base for classes in object-oriented programming. Got it? Now, how much memory is allocated for these members or variables? You see this. The memory allocated to each structure variable is equal to sum of all its members size. For a structure, for a structure variable, how much memory is allocated means that is equal to sum of all its members size. But the memory allocated to each union variable is equal to maximum of all its members size. So this is the biggest difference we can say between a structure and union. So all the members of the structure will have their own memory space, but all the members of union share the common memory space, right? But if you wanted to know the size of the structure, size of the union, not its variable size, structure size or union size you wanted to know, then for either structure or for either union, it is equal to sum of all variables size. Structure size or union size will be equal to what? Sum of all its variables size. Okay? Are you following it or not? Everybody, please confirm. Let us have an example. Please confirm, everybody. Are you following it or not? Arun, Trivikram and everybody. Let us have an example, guys. Suppose I create struct xyz. I say int I char j float k v1 comma v2. In the same way, here I am defining union xyz int I char j float k v1 comma v2. Hi Shyam, good evening. Now, I am taking a 16-bit processor. So 16-bit processor means I can say one integer size is 2 bytes or 16 bits. So for I, 2 bytes memory is allocated, for j 1 byte, for k 4 bytes because it is float type. But they are not allocated independently on the variable name. So for v1, 2 plus 1 plus 4, that is 7 bytes memory gets allocated. So this is for I, this is for j, this is for k. Similarly, for v2 also 7 bytes memory gets allocated. So size of every structure variable is equal to sum of its members size. But if you take unions variable v1, it is max of this 2, 1 and 4 bytes. So max of 2, 1, 4, that is 4 bytes will be allocated for v1. Similarly for v2. This space is shared by all I, J, K are all the members. Got it? But if I want, what is the size of XYZ? Whether it is a structure or union, that is equal to V1 size plus V2 size. For structure or union, it is V1 size plus V2 size. That is 7 bytes plus 7 bytes, that is 14 bytes. If it is a structure, that is 4 bytes plus 4 bytes, that is 8 bytes if it is union. So size of the structure or size of the union is equal to sum of its variables size, whether it is a structure or union. Understood? Shyam, Trivikram, Arun and everyone? Right. And guys, it is possible to define one structure inside another, or one union inside another, or structure in union or union in structure. This is what we say nesting, nested structure or union. That means inside the structure you can have another structure, or inside the structure you can have union, or inside the union you can have structure, or inside the union you can have union. So it is possible to define one in another in all these 4 ways. Let us have an example for this. Look at this example. I have struct ABC in which there are member A, member B and another member, that is inner structure. And for inner structure I have the variable V3, V4 and V1, V2 are the variables of outer structure. So let us take the same 16-bit processor. Let us take the same 16-bit processor. If so, for A 2 bytes is allocated and for B 4 bytes allocated. For x of 10, for one integer 2 bytes, so for 10 integer 20 bytes allocated, and for one character 1 byte, so for 20 characters 20 bytes. Now what would be V3 size? V3 size would be 20 plus 20, 40 bytes. V4 size would be 20 plus 20, 40 bytes. So V3 will have 40 byte, V4 also will have 40 byte. But what would be the size of V1? V1 size is equal to sum of its members size. What are the members of ABC? One int A, another float B, other structure XYZ. What is the structure XYZ size? That is sum of its variable size, that is 40 plus 40, 80 bytes. So now 3 members in the ABC structure. One is int A, other is float B, other is struct XYZ. So sum of all, that is 2 plus 4, 6 plus 80, 86 bytes for V1, 86 bytes for V2. Now what is the structure ABC size means? I can say 86 plus 86, that is 172 bytes. Got it? Now you take the other example. I have defined union inside the structure. Let us identify what would be the memory now. For integer A 2 bytes, float B 4 bytes and x takes 20 bytes, j takes 20 bytes. Now as inner member is union, union will allocate max of its members size. What is max of 20 comma 20? 20 only. So for V3 20 bytes, for V4 20 bytes. What is XYZ size? Sum of its members size, the variable size, that is 20 plus 20 40. Now it is V1 is variable of structure. So sum of its members size, 3 members, int A, float B, union XYZ. A size 2 byte, B size 4 byte, XYZ size 40 byte. So this is 46 byte for V1, 46 byte for V2, and structure ABC size 46 plus 46, 92 bytes. Got it? Now let us have other two combinations. Structure inside the union, union inside the union. So the left one I have defined structure inside the union. So this would be 2 bytes, float 4 bytes, and here 20 bytes, here 20 bytes. I am taking 16-bit processor, again don't forget that. So one integer takes 2 bytes. So for V3 20 plus 20 40 bytes, for V4 40 bytes, and for XYZ, that is 40 plus 40 80 bytes. Now V1 is a variable of union. So max of its members size, max of 2 comma 4 comma 80 80. Hence V1 size would be 80 bytes and V2 size would be 80 bytes. And what would be ABC size? Union size, total union size is sum of its variable size, that is 80 plus 80, 160 bytes. Now the last combination, union inside another union. Let us analyze. For A 2 bytes, for B 4 bytes, for int x of 10 20 bytes, for j of 20 20 bytes. Now for V3 max of 20 comma 20 20. So for V4 also 20. Now union size is 20 plus 20 40. Now V1 V2 are again variables of union. So max of 2 comma 4 comma 40 40. Hence V1 size would be 40 byte, V2 size would be 40 byte, ABC size would be 40 plus 40, 80 bytes. Got it? Now I think it is clear. Structure inside the union, union inside the structure, structure inside the structure, union inside the union. Is this clear for everybody? Yes. Great. And guys, it is also valid to define one structure or union variable as member of another structure or variable. What does this mean? Suppose there is a struct ABC int I char j float k. Okay. Now struct xyz int p char q struct abc of v2 v1. Look at this. Look at this. Now structure xyz has 3 members. What are they? P, Q, V2. But V2 is variable of another structure. Like this also we can define. Now on the name of V1, how much memory is allocated? Let us observe. For integer 2 bytes, let's take a 16-bit processor. Okay. Char q 1 byte, and another memory is variable of structure ABC. So here 2 bytes, char 1 byte, float 4 bytes. So its variable means it will get sum of all the members size, that is 7 bytes. So now for V1, total 10 bytes memory gets allocated. In that, P occupy 2 bytes, Q occupy 1 byte, remaining ABC structure V2 variable occupies 7 bytes. That means here we have I, J, K. So this is how you can understand. Now, if you want to access these inner members, how you can access? Through variables you can access, dear friends. For example, I would like to access here X. How I can access? I can say V1 dot V3 dot X, or V1 dot V2 dot V4 dot X. Similarly, V2 dot V3 dot X or V2 dot V4 dot X, like that. Outer variable, inner variable, then member. If it is a pointer variable, we take arrow operator. Simple. Okay. Now, look at this question. It's a gate question, dear friends. Consider the following C declaration. Struct short S of 5. In that, union float Y long Z U T. Assume that objects of the type short, float and long occupy 2 bytes, 4 bytes, 8 bytes respectively. The memory requirement for variable T, ignoring alignment considerations. Alignment consideration is little a vast topic, but let me tell you the shortcut. Alignment in the sense, whichever takes the maximum size, maximum of the members size, allocate the same size to every member. That is the simple shortcut I can say. If you consider alignment consideration, Shyam, through that variable only you can, but here you are asking, right? Here you are asking, or here, as I said, outer variable, inner variable, member. Both are normal members, we use dot operators. If anyone is pointer variable, we use arrow operator. Okay? Yes. So what would be the answer for this question, dear friends? Shyam says 18 bytes. Okay. What about you, Trivikram, Arun and others? Let's see. One short occupied 2 bytes, as there are 5 array of 5 short variables, 5 into 2, 10 bytes would be allocated for this array S, and one float takes 4 bytes memory, one Z takes 8 bytes memory. Now this union is having only one variable, that is U. You know, union will give size that is equal to max of its members size, that is max of 4 comma 8 bytes. So this member, as it is only one variable, union size and its variable size would be same, that is 8 bytes. Now for T is what? Variable of the structure. So it is getting the memory that is equal to sum of its members size, that is 10 plus 8, 18 bytes. So yes, 18 is the right answer. Understood everybody? Understood everybody? So this is what the concept of nested structure or union. And next class we will discuss about user defined data types, that is tomorrow, Wednesday, sharp at 6 p.m. So let us meet again tomorrow at the same time, 6 p.m. Till then, wish you all a happy learning. Have a great time. Take care. Please do like the session, share and subscribe to our YouTube channel, and also enable the notifications. Thank you so much for joining the session, dear friends. Keep learning, keep growing. See you tomorrow sharp at 6 p.m. Have a great time. Take care. Bye-bye.